Okay, so we've got these questions here on algebraic proof. Most algebraic proof tends to be all about odd and even numbers. This one is a different one to that, but if we say that n is an integer, any integer, then 2 times n is guaranteed to be even. And therefore, 2n plus 1 is guaranteed to be odd because you take any even number and you add 1 to it, and it's an odd number. Likewise, 2 times any even number minus 1 is going to be odd as well. Now, the second one that I put the asterisk next to is actually a better, in my opinion, a more useful formula to use, because if you take all the positive values for n, all the positive integers, start off with the lowest one, which is obviously 1, then 2n would be 2, 2n plus 1 would be 3, which means you skip out the first integer, the first odd number. If you do 2n minus 1, you do get 1. So that's useful. Now, with this question, we said we have to prove that the sum of 3 consecutive integers is divisible by 3. So let's call the sum of 3 consecutive integers, call that x. What we're trying to do is we're trying to get that we're going to try to rearrange it to be in this format, where we have 3 multiplied by something, where the something is an integer. If that something is an integer, then 3 times that something is guaranteed to be divisible by 3. If you think about it, whenever you multiply a whole number by 3, then the answer is in the 3 times table, therefore it's divisible by 3. So how do I represent in algebra the sum of 3 consecutive integers? Well, again, I'm going to say that n is an integer. It could be any integer. And I'm going to add it to n plus 1. Okay? Don't actually need the brackets, but just to emphasize the point, that would be the next number, right? And then we would add it to n plus 2. And you might be able to see where we're going to go from here. I might actually see if you can take over from here. This is essentially what x is. With a little playing around, I reckon you could probably get it to be into that format. So I'm going to pause the video and see if you can do that yourself. So basically, you can see that we're just having this added to that, and then that's added to that. The brackets don't do anything at all, because if I'm adding something plus something, then it's the same as adding that and then adding that afterwards. So I can simply just remove all the brackets. And while I'm at it, why don't I put the ends next to each other? So I end up with just simply 3n plus 3. Well, this last step should be fairly straightforward now. We see we've got to take a factor of 3 outside the bracket, and we end up with n plus 1 inside the bracket. Well, if n is an integer, then clearly n plus 1 is an integer. So we can just label that integer, and that's the answer. So that's probably going to be enough. The answers actually then say just has therefore divisible by 3. But I mean, considering that was in the question anyway, it's probably going to be fine to put it without it anyway. But anyway, so that's the answer. That's the first one. I'll pause the video and let's just have a look at the next one first. We have to prove that n plus 6 squared minus is always a multiple of 8. N is once again an integer, so that's our next one. We're going to see how it's a multiple of 8. It's a similar sort of method as the previous one. Okay.
Yeah.
So previously we had x, so we had x is equal to 3 times some integer. So I guess what we could say is we could say we're getting it to equal to 3y, where y is an integer. So what did we find out? Well, after a little bit of rearranging, we found out that y was n plus 1. So we're doing the same sort of thing. All we have, it doesn't matter what's inside the bracket. If it was, for example, n squared plus 5, that would still be an integer. Because any integer squared is also an integer. You add 1 to it, which in fact you add any integer to it, that's also an integer. So what we want to do in this case, we want to have that is equal to, we want to say multiple of 8 times, well, let's call it y again. And where y is an integer. So I'll just write it out here. What I think we're going to want to do is expand first and then sort of tidy it up and see if we can somehow get 8 outside the bracket, then put something inside the bracket that we can say is an integer. So we've got n plus 6 all squared is going to be just n plus 6 multiplied by n plus 6. And then minus n plus 2 multiplied by n plus 2. And that would give me n squared plus 12n plus 36 minus n squared plus 4n plus 4. Oh, hang on. That would be in brackets though. So if I got rid of the brackets, then these two pluses turn into minuses. Because I'm minusing positive things, so they become negative. And I should have written squared there. Well, I must have forgotten. And so we can see that the n squared cancel out. That's quite useful. And then we've got 12n minus 4n, which is 8n. And we've got 36 minus 4, which is 32. Okay, so now we just look at what to do next. Okay, good. So we factorize it, we take 8 outside the bracket. Inside the bracket, we've got n plus 4, and if n's an integer, then clearly n plus 4 is an integer. So there you go. All right, I'll stop the video there, or just put it there, and we'll have a go at a few more now.